all these things we have discussed, correct? So this is all about our substation. Okay, this is how we create the SLD uh, for any voltage level from 415 voltage to any voltage level that is 765 kV. Okay, so now we will discuss about the different bus bar switching scheme that we have in our for our system that we are taking. Okay, so now here what we will do, we were focus further. I'm now in the further slides we haven't put it all the equipment. So only the circuit breaker is present. Okay, and isolator. To understand, like we have put it circuit breaker and isolator to understand how the power flow take place. Okay, and to understand that when the fault occurs on any line or any bus. Okay, so what will happen into the system? So this is this these two factors we will take, we will understand in further slides along with the bus bar switching scheme that we have. So with that you understand the advantage disadvantage of different bus bar switching scheme, why we are taking any switching scheme. Okay, okay, so here you can see this is single bus bar system. Okay, and the there are again the same number of feeders like previous one two line bay, sorry, three line bay and one transformer bay. And here you see on the last feeder, we can take the power and receive the power. Okay, then this is taking the power, this is giving the power. Here also we can take and receive the power with this feeder. So our system is healthy right now. Okay, as you can see, the system is completely healthy. It is working in a healthy condition. Now, what will happen? Suppose there is a fault occurs on our feeder, or suppose we have taken the circuit breaker in the maintenance. Okay, so what will happen? This circuit breaker get tripped, and a complete power supply will be interrupted for this particular feeder. Okay, and other feeder will work in healthy condition just like before. Okay, so this is what three feeder are in healthy condition, one feeder in unhealthy condition stop working. Okay, when the fault occurs on this line or we have taken any equipment in the maintenance. So once the fault you will clear it again, this feeder will work in a healthy condition, correct? So this is one condition. Then second condition, when we have the fault on the bus bar. So in that case, what will happen? The fault will happen on this bus bar. All the feeders which are connected to this bay, so this bus, okay, will got interrupted. So all the circuit breaker will be tripped. Now it means your complete substation is in blackout because no feeder is working in a healthy condition. So substation is in unhealthy condition, in blackout, complete. There is no power supply the substation is dealing with at this particular moment due to the fault on this bus bar. Got it? So here you can see when we have a fault on a feeder, then one feeder is interrupted. When you have a fault on the bus, all the feeders have the interruption, power interruption. So this is the two things. Okay. When you clear the fault, then again the system will work in a healthy condition. So this single bus bar system we are using up to 33 kV voltage level. Then advantage is like lowest in cost, a small land area required, easily expandable, simple in concept and operation. Simple, there's no very little logic, very simple logic that you need to create. about the operation. Okay. Then disadvantage, lowest reliability. Lowest reliability with respect to further that further bus bar switching scheme that we will discuss in further slides. Failure of a circuit breaker causes loss of the feeder that we have seen, and bus fault causes loss of the entire substation. Now, how to get over this? So, main disadvantage is loss of entire substation in case of bus fault. So, we need to do something that can avoid, so that we can avoid such condition. Then requirement, avoid loss of entire bus, entire substation in bus fault. How to achieve? We will achieve to avoid this loss of entire bus by sectionalizing the single bus bar. So with this, we have the introduction with single bus bar with bus coupler, sectionalizer on single bus bar scheme, whatever you can call it. So this is our old system, if you remember, correct? Now suppose fault occurs on this feeder will interrupt it. Then when we have a fault on this bus bar, again the same way, complete sys- substation will get interruption. Then here what we have divided it. Okay. So we have divided, we have made two parts. One with bus section one, one with bus section two. So this is working in a healthy condition and this will not work in a healthy because this is a fault. So these two circuit breaker will get tripped. And here we will connect with again isolator and circuit breaker. So what will happen then when there is a fault? All these three circuit breaker will be in tripped condition. And these two will work in a healthy condition. Okay. So this is how. So with respect to the previous one, the reliability of the system is increased. Correct? You can rely on this system more than the previous system. Why? Because whenever there is a bus fault happening, the complete substation will be in blackout. But here, when you have a fault on bus, then that particular bus section will have the power supply loss. Okay. When you clear the fault, again the system will work in a healthy condition. Then sectionalization of bus bar. So this bus bar switching scheme we are using up to 66 kb, flexible operation, higher reliability than single bus bar scheme, isolation of a bus section for the maintenance, loss of only part of the substation for a bus fault. Okay. So these are the advantage with respect to the previous one. Then disadvantage, again, there's a fault on the feeder and we are losing a feeder, and a sectionalized bus bar arrangement has the higher cost. Why? Because we have the additional circuit breaker and isolator are required for the sectionalizer, and due to which the engineering cost, the equipment cost, okay, civil work, so everything will increase. So that's why the price of this system is more than the previous system. Then what improvement can we do? So disadvantage, like we are circuit breaker failure are more than bus fault. Okay, so generally as per study, circuit breaker failure on the feeder is more than the bus fault. So thus we lose important feeder in case of the circuit breaker outage. And to avoid this, we should use bypassing the circuit breaker, faulty circuit breaker. So we will make the system in such a way that we can bypass the faulty circuit breaker. So with this, we have the inception of main and transfer busbar arrangement. So here you can see, this is again the same scheme, just like before single busbar. When you have a fault on this, this will the feeder will have the interruption. Then you just bypass it by using isolator and introduction of bus 2 or transfer bus. So we will call it transfer bus. Okay, transfer bus. And this is our main bus. So that's why we call it main and transfer bus bar switching scheme. Okay, so why we have introduced this? We have introduced this scheme in case when you need a feeder in a priority. Suppose this feeder have the supply into some important place like hospital, like metro, like you say any um, country specific parliament. Okay, so in that case, it is we adopt such busbar scheme in which we are giving priority, which in which we are giving priority to the feeder supply. Correct. So here when we have the fault on this feeder, so we are giving priority, and in this case, this feeder again runs. You see, you just close this circuit breaker, and the power from here will go like this way and will go like this way.
सभी क्रेडिट कार्ड होल्डर्स के लिए एक बिग अनाउंसमेंट जीएफएफ मुंबई 2024 3 डेज इवेंट 28 से 30 अगस्त तक होने वाला है और मैं आ रही हूँ
Okay, so like this way, the power will flow into the system. So this is how you can bypass the faulty circuit and we can use. So here you can see we are adding the isolator, not the circuit breaker. And now when you transfer this feeder with into onto this bus coupler, okay, so whenever there is a fault occurs on this line, okay, suppose there is a line, in this line the fault occur, in that case which circuit breaker will get tripped? This circuit breaker will get tripped. Okay, so as of now, this transfer bus coupler feeder or this TBC circuit breaker is now the line circuit breaker. So this circuit breaker act as a line circuit breaker when it works for this line. Okay, so this is, and at a time you can transfer only one feeder. Correct. So suppose this is working. Now again that the fault occurs here or somewhere you want to do maintenance. So you cannot transfer this circuit, this feeder at the same time. So at a time you can transfer only one feeder. Okay, either this one or either this one. Not these two feeder at a time you cannot transfer to the TVC. Why? Because you need a circuit breaker for that particular bay, that particular feeder. So this circuit breaker is acting as a feeder circuit breaker for this feeder as of now. You require second circuit breaker to act as a circuit breaker of that this feeder. So we don't have, we have only one circuit breaker. So at a time only one feeder can be transferred. Okay. So this thing you can note. And then when we have the fault on this feeder, sorry, on this bus bar, so what will happen? Complete system again will go on the blackout because all this feeder are connected to this bus only. Correct? When you clear it, so again the system became healthy. So main and transfer bus bar switching scheme we are considering just because to give a particular feeder preference. Okay, any particular feeder that preference. So that's why we call it transfer bus coupler, transfer bus and main bus. Then main and transfer bus we can use up to 132 kV. Then advantage, circuit breaker outage maintenance does not disrupt the service of the feeder, as we have seen. Reasonable in cost, small land area, easily expandable. Disadvantage, bus fault causes disruption, and additional circuit breaker is required for the bus type. So any doubt till now? Anyone want to ask anything in this or in the previous one? Anything you want to ask? Any condition or something? Nothing?
No, sir.
Okay, okay. So here main disadvantage are again the same, like bus fault in a substation having more number of circuit cause greater interruption of the power. Though the bus fault is less, in main and transfer bus bar arrangement, bus fault result the loss of entire substation. So to avoid such too many circuit, we need to do something. So by how to achieve this target, we are putting another main bus. Okay. Then with this, we have double main bus bar system. So in this, if you see, so this is again the same feeder or same bus bar. Then here, what we have do, we have the bus bar 2 and we have the connection like this way. So if you can compare, can anyone tell what is the difference between main and transfer and main this double bus bar scheme, the connection wise?
In this, the connection is given before the circuit breaker.
Sorry, come again.
In this system, the alternate connection is given before the circuit breaker.
Alternate connection, मतलब
But
disconnector
yeah,
connection.
main bus bar 2.
Hmm.
So in this, I think in all the feeder, there is a separate connection to the bus one and bus two. But the earlier figure, it was another connection, parallel connection was provided. Not for
Here
the all the
also we
feeders.
have given the bus bar 2, you see.
Yeah, in this there is a transfer bus, and as well as the circuit above the circuit breaker, there is another connection is provided to the bus two for transfer bus.
Okay. So you can see like we have the connection here, okay, of this isolator. And in our double bus bar scheme, we have connection here. So we have shifted this connection to here. Okay, if you see, see, earlier it was here in main and transfer. In double main bus bar scheme, we have the connection here. Correct? So this is the difference between the two. So with this, you can see both the bus bar scheme are same. Only the connection is different. Only the tapping of this isolator is different. Here we are doing here, and in previous one we are doing before the line isolator, after the line isolator, if you say from the downside. So after the line isolator. So this is the difference. So it means your investment wise, your system is same, correct? Investment your system is same, and almost logic and everything, civil work, everything, your system is remain the same. Okay. Got it, everyone? Now here you can see the system is working in a healthy condition. Okay. So with this, you can see the first two feeder are connected on bus 2. And the last two feeder are connected on bus 1. Okay. Now here you can see these two are connected on bus 2, these two are connected on bus 1, and this is connected, interconnected. Now suppose fault occurs on this feeder. So this feeder will get interrupted, the power supply will get interrupted. Okay, this will get tripped. Other feeders are working in a healthy condition. Now, when you clear the fault, again it will work in a healthy condition. Now suppose you have the fault on this bus bar. So the feeder which are connected to this bus bar 2 will have the power interruption. So these two circuit breaker along with this bus coupler circuit breaker will tripped, will trip. Okay, so here you can see. And other two feeders which are connected to bus 1, they are still in healthy condition. Okay, so this is, you can say, single bus bar mode. If you remember the sectionalizer bus bar mode, correct? So when you clear the fault, again it will work in a healthy condition.
Yeah,
Sorry.
sir,
Huh.
there is some doubt on this. I think the main bus to have will be having the fault, or some base, due to some base there would be a fault.
No, I'm not getting your question. Come again.
As you were said before that main two having the fault, and for that reason this substation and first substation and power station are interrupted, right?
Mm-hmm.
So my question is, the fault occur in this case in base, like the substation base or the power station base, or in the main bus bar 2?
Main bus bar 2.
So there is a fault in main bus bar 2.
Yes, yes. So fault occur on this bus only.
Mhm. So for this coupler, bus coupler, and as well as this substation and power station also are being interrupted.
Correct, correct. Because
But
they are,
there could be,
yes,
yeah,
there could be.
there could be either base where the, let's say, the fault occur, or only the bus could be isolated, right?
Yeah, that we have discussed. If you remember, if you see, suppose here fault occurs on this way, somewhere on this line, or you did take the circuit breaker and equipment on maintenance. So this will interrupt it. This circuit breaker will get
Yes.
tripped, and it will have the interruption of a power. So it will work like this way. But when you have the fault on this bus bar 2, or either bus bar 1, okay, both case will same. Okay, so the feeder which are connected to this bus bar will have the power interruption. So what you will do now, you will automatically these three circuit breaker will be in trip condition, and then what you will do, you just switch on, close these isolator, because isolator is an offload device. So you just close this isolator and open this isolator. Okay, after tripping, just open these isolator and close this isolator. Okay, so after doing this, what will happen? And then you just close the isolator. After closing this isolator, opening this isolator and closing these isolator, okay, the power will flow. You see here, Okay, let me delete it so that you can understand in clear way. So here you can see you have the fault still, but you have transferred these bus on this bus bar. Okay. So all the all the four feeders are in healthy condition. In spite you have a fault on this bus too. So how to do this? I'm going one step back. This is how the things happened. Then what do you have to do? You have automatically these two circuit breaker will trip when there's a fault. So in that case, you have to close. You have to open these two isolator, and you have to close this isolator, and then you have to on or close the circuit breaker. So once you close the circuit breaker, automatically this condition will be achieved. Okay, got it?
Or in case of a fault on bus 1, the other two feeders also will get affected, right?
Yeah, it's a vice versa. So suppose if you are taking like bus 1 fault, okay, rather than bus 2. So in that case, what will happen? These two circuit breaker will be in trip condition and this, okay. So what you have to do again, if you can imagine, like you have to these are in trip condition, then you have to uh, uh, open this isolator, close this isolator, okay, and then close this circuit breaker. So in that case, what will happen? Again, the power supply will go from here because you have a bus 1 fault. So power will be gone from already the power is connected from here. So when you close, so power will go from the downside. So again, it will be healthy.
Or in case of a fault on bus 1, all the feeders will be affected, right?
In case of bus 1,
Bus 1,
no,
all the
in when in this condition, which condition? Now, if you see that this condition, like I will go one step back. Now this is the condition. Our system is in healthy condition. Okay. Okay.
okay.
All the feeders are working in a healthy condition. Now kindly note which feeder is connected where. This feeder is connected here. 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 Okay, and this feeder is connected on both the bus. Got it? Now
Okay.
fault occurs here. These two circuit breaker will in trip condition automatically because these are getting the power. So the fault occurs here. This fault will spread everywhere because these are connected on this bus. This bus is connected on these feeders. So the wherever that because this bus bar act as a node, I told you earlier. So from wherever it is getting the power or delivering the power, all the things will be hampered. So in this case, these two feeder will be interruption. So these two circuit breaker will trip. So as I told you, you can just connect this isolator. Okay.
So coupler also will tip.
Sorry.
Coupler also will tip on this condition.
Come again.
Sir, coupler also tipped on
Coupler
this.
is also trip. Coupler is also trip because why? Because it is connected to both the bus. You see earlier. Yeah, because this is connected. So if you cannot trip, so suppose this fault current will flow, and if you have connected here, it will go into the bus 1. Now bus 1 will also affect, then automatically these two circuit breaker will also trip. Correct. So for both to protect the system, the bus coupler will be in a trip condition. Okay. So this is how the system will work. Once you clear the fault, again system will be in a healthy condition. So the advantage is like we can use double bus bar scheme mostly into 20 kV. Bus bar outage maintenance does not disrupt the service of any feeder. Reasonable, fairly small and easily expandable. Circuit breaker outage cause disruption of a service of that particular feeder. Now here you can see double bus bar, as I told you, double bus bar and main and transfer. Both are alternative of each other. Correct? Both have the same investment. The only difference is that in double bus bar system, we are giving priority to the fault of bus bar or outage of bus bar. In main and transfer, we are giving outage priority to the outage of line feeder. So this is the difference between these two. So based on the application where you are installing your substation, that will come into the play. Okay. Another thing that can happen like mechanical interruption or power interruption of your isolator may happen. Both bus fault, circuit breaker outage are to be taken care of. And by using one of the main bus as a main come transfer bus, so we have the other alternative like double main come transfer bus bar arrangement, which is a combination of double main and main and transfer bus bar scheme. So with this, we can achieve both. So suppose you have a fault on bus and on line feeder at the same time, you can. So here you can see, this is just like the previous double main bus bar scheme. If you remember, one isolator is connected here, one isolator in the middle of that VA. But here the representation is different only. Connection is same. Okay. So you can note like this feeder is connected to the bus 1, bus 1, bus 2, bus 2. So when you have fault on this, the feeders that are connected to the bus 1 will have the interruption. And the same way I told you in the previous section, previous bus bar scheme, you can transfer the bus. So we have transfer the feeder on bus 2 by opening these isolator and closing these isolator and then close the circuit breaker. So easily you can transfer the power, make it healthy. Okay. So still you can see there's a fault on this bus bar. Now, when you just clear the fault, so again the system became healthy. Now suppose there's a fault on this feeder. Okay. So the power will be interrupted for this particular feeder. Now when you transfer the system to this bus bar scheme. Okay. So when you transfer your system to this bus bar, by adopting, if you remember, this is the main and transfer bus bar scheme mode. So in that case, we are giving the preference to the feeder by adopting this isolator connecting. So when you have this connection, you just bypass this faulty circuit breaker and you can connect it. Okay. So this is how we can achieve in this this thing. So bus 1 became your bus.
But
Yes.
sir, but in this case, does not we like unprotect the system if we are
In
going
this
for
case,
only isolator?
sorry,
Yeah,
no, come again.
we are connected. We are bypassing the CB and isolator, right?
Yes,
As
yes,
you
yes.
are said that we are we are bypassing the CB with the help of isolator, but isolator is not protecting the substation, like let's say substation or power station or load center. So if any fault occur at this moment, then the entire substation will collapse, right?
At this point, if along with this fault, if there's a fault occurs, it depends on where it is occurring. So based on that, the decision will be. Suppose if fault occurs here on this line, okay. So what will happen? This circuit breaker will trip. Okay. When because it is connected to this bus. Okay. So if you see this bus is connected to which? Now this feeder is not connected. This is taking power from here. This is taking power from this bus. This is feeder is taking from the power. So when the fault occur here, so what will happen? This fault flow here and it will trip this circuit breaker. Now fault occurs here. If so, this circuit breaker will trip. Now fault occurs on this bus. Then what will again this circuit breaker will trip because at this time only this is connected. Correct. This circuit breaker is connected at this time. Now, if fault occurs here, then complete blackout. So it depends where the, now in this case, where the fault is occurring. So it depends. So you need to do what? Now this is the condition. You need to check how the fault current will flow and where it will flow. Okay. So as I told you, suppose fault occurs here, then what will happen? This fault current will be like this way. It will come. So this feeder is not connected here, so no power up to this point. The current will flow, fault current. Already it is disconnected, no interruption. Here also it is disconnected, so no interruption to the system. Then it will come there. It will flow there and here. There's a already disconnected, no power flow further. So no interruption. Again here you can go here and here. No interruption of the uh, because these are not connected, so no interruption. Here it will go because this is connected, so it can flow. Now this is a circuit breaker, so automatically it will trip. So you need to check how the fault current is flowing, where and where it is connected basically from the healthy condition. So healthy, unhealthy, healthy part will be isolated. So wherever the unhealthy part,
But sir,
hmm,
Pavan sir, if
yes,
in
yes,
this case this coupler circuit is failed to open or clear the fault, in that case the all the other station where the power is coming from, that will be feeding the fault, right, continuously, and there won't be any other option to isolate the faulty part.
yes, yes. If this circuit breaker
So how come
fails,
this is a reliable system?
how come this is a reliable? So see, there are the cascading fault. This already there is a fault. If again there is a fault, okay, again there is a fault. So multiple faults will not happen at the same time in the system. Okay, fault occurring here, then fault occur here, then fault occur every part. It is happening like after 5 seconds or because when happen the fault occurs, so within a 100 millisecond or 30-40 millisecond it will be cleared. Your circuit breaker will be tripped within a millisecond. Correct.
No.
And
Let's say if
if
any
it fails, and if this circuit breaker fails, so then what will happen? If mechanically fails, then LBB come into play. 50 BF protection function. Okay. So 50 BF is local breaker backup or breaker failure. Okay. So what will what it will do? it will trip all the feeders circuit breaker which is connected to this bus.
Yes.
So here in this case, what will happen? These three feeders are connected. Automatically, it will trip these three circuit breaker. And along with, because this is an interruption, mechanically interrupted. So with this, automatically all three circuit breaker will be in trip condition. Okay, so it will wait for the setting. So LVB setting generally we put 200 millisecond. So after 200 millisecond, it just wait. It will check that circuit breaker is whether operating or not. So the timer will start once the trip will happen. So automatically the initiation will be started. So it will wait for 200 millisecond. Then after 200 millisecond, it will check again the current or the voltage is going. Yes, going. So automatically it will give command, and all these circuit breaker will be in trip condition.
Yes, sir.
Okay,
Hmm.
Jugal?
Yeah, yes, yes.
Okay, so this is how the system
But
will work.
do we bypass like this in a real condition, or like this is
Yes,
only
yes.
the schematic version?
No. We are using this busbar scheme in many substation. It is not just like to showcase you, but
Mhm.
this main and transfer, double main and transfer busbar scheme using in multiple substation. Different utility have different concepts, so they are using it. In this case, you
So in
have
this case, why we can't use CB then after isolator?
CB after.
Isolator. This short we are doing, right? Like the pedal bus we are doing, right? So here also why you can't use CB?
Circuit breaker. Where
Yeah,
you are saying this circuit
yeah.
breaker or this circuit breaker? Which circuit
From
breaker?
where no, from where we are taking another path, right?
This one.
Yeah,
Yeah.
yeah. Why
Uh-huh.
we can't use circuit breaker over here also?
Here
Mm-hmm.
in this feeder you are saying you can use.
Yes, yes, yes.
You can use, but people are not using. Why? Because the cost will increase of the system. Cost will increase. So what you have to do, you have to make a system with minimum investment and maximum output. You can use the circuit breaker here. Yes, you can use. No one will stop you.
But sir, in
Okay,
this case,
but
how come we
what?
ensure the distance
See,
protection?
I will come to that. If you will use the circuit breaker here, the cost of your project will increase automatically. No one wants to invest this much of amount in this particular thing. Okay, so just to avoid the investment, people are not using. So they want the system with minimum investment and maximum output. Okay, so that's why we are not putting the circuit breaker in any other feeder. Okay, this is the reason. There's no compulsion. Like you can, if you are the private player or you want is your own system, you can use multiple circuit breaker. Okay, you can use the multiple circuit breaker wherever you want in your system. No one will stop you. Okay, yeah. In
Sir,
this
one thing is
case,
that how
distance,
come
yeah.
we ensure the line protection in this case if one circuit breaker is out of service or it's in maintenance?
If this circuit breaker is out of condition, then how the line protection will work? You are saying.
Yes, yes,
So simple line protection will work because here the CT is there. Okay, CT will be here somewhere. Okay, got it. Now line protection
yes.
is work on which what principle?
IDFT, right?
Sorry,
IDMT, I think.
ID IDMT.
MT. Yes.
What is the full form of this?
What's
Inverse definite minimum time.
Okay, so why we are using this? Anyone can tell? Other person?
The time of operation is inversely proportional to the
To
fault
the
current.
to the fault
Fault
current.
current.
Yeah. So this is the principle. But what is this? What is this IDMT? This is a principle. This is their characteristic. Inverse current is inversely proportional to the fault current. Sorry, fault current is inversely proportional to the time of the operation of the circuit breaker. So this is it is function. What basically it is doing? Okay. So what where no one knows. Okay, good. So this IDMT is not the principle of the line. So the line principle is impedance protection. Okay, this is
Yes, sir.
overcurrent fault. Okay, this is something different. So because you don't know, that's why you have the doubt, this doubt how the line protection will work. So this it is the line principle or distance principle is working on which principle? Impedance protection. Okay, impedance is the principle on which it is working. Now what is impedance? Can anyone tell what is impedance? What is impedance?
Impedance is the opposition offered to AC current flow.
Sorry, impedance is the
Resistance offered to AC current flow.
impedance is the resistance of AC circuit.
Offered to AC current flow.
Actually, I'm not getting your voice
R
clearly.
plus XL,
Anyone?
sir. Impedance is R plus XL.
R plus XL.
XL.
Okay, so that is Z.
Yes, sir.
Yes.
Okay, great. So, and other person is telling what it is. Impedance is the ratio. No, what he is telling. I just forget. Chaco, you are telling na something. What you are telling?
I said it is the resistance offered to AC current flow.
To AC current flow. Okay. Yes, you are right. This is
So
a
we can
resistance.
rewrite also V by I, right? V by I is equals to R. We can rewrite also.
Okay, so you are saying
Or
this
Z.
Z is also B by R.
I.
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 Okay, great. So this line protection principle is working on impedance principle. Okay. So line protection or distance protection have the principle of impedance. Okay. So impedance is a principle on which your line protection is working. If the line length is higher, if not, then the line differential protection is there. Okay. So differential protection will be the separate one. Okay. I'm not going. So suppose the impedance protection is there, then as you told, Z is equal to B by I. Okay. So what input it required? What input is required? B and I. Okay. So this CT, suppose the CT is connected here and the relay is connected here. So what it is required to operate? It is required the BT, which is connected here, and the current. So automatically the current is coming. Okay. So this current will come here. Okay. So to operate this relay, okay, when the line fault occurs, so this impedance protection will work. So in this, your BT and current is coming automatically. Okay. So current and B ends. So it makes your distance relay to operate. And when there's a fault occurs on this line, this will give trip command to this circuit breaker rather than this circuit breaker. Okay. So rather than give this circuit breaker command, so we have to make a logic in the schematics. Okay. We have to make a logic in such a way that when your line is in healthy condition and it is working with this, suppose line is in healthy condition. So in that case, this circuit breaker act as a main circuit breaker of the line. And when you transfer, when this isolator is in power, So it understand by the system automatically that this is out of system and this circuit breaker is in the system. So in that case, we have to wire the cables of this circuit breaker to this relay again. Okay. So with this, when this isolator is on automatically, so we will give the contact of this isolator in the logic, or when we create the logic or bus bar scheme logic. So then we will give the contact of this isolator here. So automatically it understand that this isolator is on. So automatically it understand that this circuit breaker is now the main circuit breaker. So as soon as the line fault occur, this relay will give trip command to this circuit breaker. So this is how the line protection will operate. Got it, Jugar?
Yes, yes.
Okay. So anyone have any other doubt? Any doubt? Okay. Okay. So this is how the system will work in case of the fault. ये कैसे जाएगा ऊपर? Okay. So double main come transfer bus bar scheme we are using up to 220 kV substation. Okay. Then again the same, we are giving here the preference to the bus bar outage. Then we are giving preference to circuit breaker outage. Okay. And then we have the disadvantage like additional isolator is required, okay, in each circuit breaker, which increase the cost. So with this, suppose there is another thing like double main come transfer bus bar arrangement outage of the circuit breaker and bus together. Suppose the fault occurs at the same time on the line and on the bus bar. So what will happen? Because here we are taking in this previous, if you remember, in the previous we are taking fault one by one. One time we have taken the fault on bus, and one time we have taken the fault on feeder, and now we are considering, suppose uh, the fault occurs simultaneously on bus bar and the feeder at the same time. So to achieve this, we have double main and transfer bus bar scheme. Okay. So here you can see this is double main bus bar scheme that we have. Okay. So this is double main bus bar scheme. This is system is working in a healthy condition. So please note this feeder is connected here. This feeder is connected here. Okay. Now fault happens on this bus bar. So automatically these two circuit breaker will trip. Okay. So the power will be interrupted for these two feeder. Okay. Now when you when you just close this isolator and transfer, basically you transfer this feeder into the other bus, okay, by opening, closing and closing the circuit breaker and isolator. So now you see earlier it is connected here, that's why I am marked. Now it is connected to the bus 1. So this is taking the power from bus 1 at this moment, and this is also in interrupted. Okay. So at this moment it is taking the power from bus 1. Got it? Now fault occurs on this line, or if you see, if you are taking the maintenance of this circuit breaker or any part along this near to this circuit breaker, so this feeder is also in interruption, power will be interrupted. Now what will happen? You just connect this transfer bus and along with this one isolator to each feeder. Okay. So what we have introduced here, so again we have introduced one TBC here. So again we have introduced one circuit breaker. Okay. So what will happen? This we are taking the power, already the power is there only in bus 1. So we have connected this TBC through this bus bar. Here the power will flow like this way. Okay, you can see, and this power will go like this. Okay, so this is how it will be connected. Got it? Any doubt in this? No doubt? Okay. So here you can see we have the simultaneous fault on bus bar. You see, same time we have a fault on this bus and this bus. Now if someone say like, now we have the fault on this bus, then automatically the system will be in blackout. Okay. So there's nothing, we have something that can avoid. We can avoid. Okay. So this is how we can make the system. No doubt, anyone? Okay. When you clear the fault, you can make the system healthy again. So here we can also use this double main up to 220 kV or on 220 kV. The same here we are giving priority simultaneously to bus bar and circuit breaker, and maintenance of bus and circuit breaker does not interrupt the supply. Additional isolator and circuit breaker required for transfer bus type. Okay. So this is an extra investment which increase the cost of the project. So interruption, maybe the disadvantage like the interruption of isolator operation. So whatever the isolator that we have mechanically, it can be, it can create a problem to the system. Interruption of power is likely to cause major disturbance if the feeder are important and heavily loaded. So to avoid such, we have 1.5 breaker bus bar arrangement. Okay. So you see, this is a single feeder we have on this bus 1. Okay, and this is other feeder on we have on other bus bar 2. Okay, but we have shown the representation in a different way. Here you can see. Then we have this again one circuit breaker. So this one circuit breaker, this one circuit breaker, and this. So we have connected this one circuit breaker along with sectionalizer, if you remember, of bus 1. So we have connected this small part isolator, circuit breaker isolator between these two feeder at a strategic location. Okay, not anywhere, but in between the line isolator and circuit breaker isolator. Okay. So the first question comes, why we call it 1.5 breaker? Can anyone tell?
One and a half breaker because in this two base share a tie breaker, and like it is 3 by 2 in which three breakers are there between two buses.
Correct, correct. Anyone want to add something?
Yes, sir. One breaker used as a main bay and another use as a tie bay. That's why it is called 1.5 breaker
Okay.
scheme.
Okay. Okay. Correct. So the right, as you already told, like if you remember from the previous discussion of previous slide, everywhere we have one circuit breaker on one feeder. Okay, if you remember in all the bus bar switching scheme, wherever we are increasing the isolator only. Okay, we are increasing the isolator only anywhere, if you remember, not the circuit breaker along with the bay. Only we are increasing the circuit breaker in bus coupler. Correct. So we, for every other feeder, we have one circuit breaker for each feeder. Now here we have introduced one circuit breaker more. Okay, in such a way that, okay, in such a way that this circuit breaker is helping to this feeder and this feeder. So someone can ask, like, already we have transfer bus coupler circuit breaker, okay, and that feeder, so why we are not? But that circuit breaker of transfer bus coupler has not that particular strategic location which is helping that other that particular, any particular feeder, such a way that we can rate that circuit breaker as a, along with that feeder circuit breaker. Okay, so only at a time only one circuit breaker we are using in the previous, either this feeder, either the circuit breaker that is connected in the feeder, or either the circuit breaker which is connected in the bus coupler. So at a time only one. But we will see the operation of this circuit breaker here in this scheme. This circuit breaker is helping to both the feeder. Okay, so that's why we have like 3 circuit breaker per 2 feeder. So that's why we call it 1.5 or 1.5 breaker scheme. So this half breaker, 50% we are giving to this, 50% we are giving to this. So that's why we call it 1.5 breaker scheme. Got it? So this is the reason. Now here we will call this as a main one, main two, okay, and this tie bay. So this is a main one bay, main two bay, and this is a tie bay. Okay, and this complete thing we are calling it what? Can anyone tell?
And dia.
Dia, correct. So we call it diameter, circle diameter. Okay, diameter, one diameter. In short, we call it one dia. Okay, in short, we call it one dia. Now, what is half dia? What is half dia? Half dia is like only
One tie
one
and
bay.
one.
Yeah, one bay along with tie bay. Okay, so only if this part is there or this part is there, then we call it half dia. Okay, so in case by half dia, because in maybe you have like 5 dia. Okay, so 5 dia means how much? 10 bay. In your substation only 9 bay. So 9 bay means only 4 dia with complete 2 number and 1 dia with 1 bay only. So this is how the half dia will be in the system. Okay, okay, then this is other system, other dia. So how many number of feeder that we have? 4 number of feeder. So here you can see the supply is in healthy, our system is in healthy condition. We are taking the power, giving the power, and everything is happening. Okay, so if you see, now we have the fault here. Okay, or any maintenance if you are doing, so you trip the circuit breaker. So how the feeder will take the power? It will take the power from here. It will take the power from here. Okay, now suppose you have a fault here. Okay, so this circuit breaker will help tie to work as a this one. Okay, then if you have a fault on this bus, what will happen? Whatever the number of feeders that are connected to this bus, the circuit breaker will be interrupted. And here you can see again all the feeders are in healthy condition. Same way here it is like this way the power will flow. Okay. Suppose the same fault at the same time, the fault here and on this bus. So what will happen? It is taking the power like this way and flowing like this way. So in this condition, you have the fault on both bus, still your all the feeder are in healthy condition. The case is that in both the dia, one feeder must provide the power and one must give the power. Okay, if suppose we have the system like this, it is also connected to the consumer, it is also connected the consumer, then this condition will not happen. Okay, you can, so there must be some power receiver and some power gaining feeder, then only this is applicable. Okay, so this is, you can see this is the most reliable system. As I shown you, wherever you have a fault, without adding anything or some already we have added here circuit breaker. So you have the complete access to the system. Okay. So that's why we are using this 1.5 breaker scheme at 400 and above. Okay, because the power requirement at 400,000 MVA, okay, this much power is required, but at lower voltage it is not required, that's why we are not using. But in case of GIS, this is I am talking about AIS. In case of GIS, we are using 1.5 breaker scheme in 220 kV also. Okay, so a flexible operation, high reliability with respect to the previous bus bar switching scheme, can isolate either main bus for maintenance, can isolate any circuit breaker for maintaining double feed. Bus fault does not disrupt, all switching done with the circuit breaker, no involvement of the isolator. Okay, so this is the beauty of this bus bar scheme. That's why it is high, highest reliability. Okay. Disadvantage that only we are using half breaker or one breaker extra with per circuit breaker with for a feeder. So this we are using where the bulk power is need to be transferred. Okay, so that's why we are using this one. Then if you need like mega power generation you have, okay, then there we are using double breaker bus bar scheme. Okay, mega power means the cost of the power interruption will be more than the cost of your substation. Okay, if you interrupted the power of any feeder, then the cost will be higher than what you if you take the double breaker in the substation. So like mega generation, you have like 2000 MVA, 1000 MVA, just like this power you are producing and transferring. So in that case, we have the double breaker bus bar scheme. Okay. So we are using two breaker per feeder. Okay. Two breaker per feeder, nothing. The same way here the fault occurs, then again you can take the power from other side. Okay, then fault occur on this bus, so all will be interrupted, but you can take the power from other bus. Okay, so this is the beauty of the system here, like not the beauty, but here the investment is more due to the because the cost is very high because we are using double breaker per feeder. So the cost is very high for this substation. But this cost, like suppose there is a this feeder will be interrupted 3-4 times in a year, okay, or 5 times in a year. The cost of interruption of this feeder not providing the power and the cost of this complete substation, you will calculate then you will find the charges, the penalty that you need to pay is higher for this. So that's why you just put this double breaker in mega substation. Okay. So flexible operation, very high reliability.